Our lesson for today is about laws of exponents for multiplication. Let's discuss about exponents. I have here a to the third power. Okay, what is your base? Your base is a. And your exponent is 3. So this given can be read as a to the third power, or it can be a to the power of 3. So it tells us a multiplied to itself 3 times, or a is used as a factor 3 times. Alright? I want to take a look at this example. I want you to observe this example. Suppose that I have x to the second power times x to the third power. Right? So the meaning of this is you will multiply x squared, or you will the expanded form of x squared is x times x. Well, on the other side, x cubed, you will multiply it, or you will expand it into x times x times x. So in algebra, it's very important to know that a variable without exponent, it's understood that there is an invisible one there. Not only x, but in any letter in our English alphabet. It could be a to the first power, or it could be b, just b. It's understood that the exponent is 1. So in this case, so what do you think will be the final answer? How many x do we have? 5. So therefore, the answer is x to the fifth power. So meaning, what do you observe about the exponent? The exponent is 2, exponent is 3. Which is simply what? Add the exponent. It becomes x to the fifth power, or just 2 plus 3 equals to the fifth power. And that is our first law of exponent. Our first law of exponent is a to the m power times a to the n power. Okay? For any non-zero real number a, and for any positive integers m and n. Okay, what will you do? A to the m power plus n. That is called multiplying powers with like bases. Let's now have another example. Suppose that you have a to the fifth power times a to the seventh power. What do you think is the answer? Just simply add the exponent. Okay, you have 5 and 7. 5 plus 7 will give you 12. And as you notice, their bases are the same. So final answer would be a to the 12th power. Okay, another example. You have y times y to the 10th power. Okay, again, as I mentioned earlier, if there's no exponent, or if you can't see any exponent, it's understood that there is invisible one. So in algebra, we seldom write it as your exponent, or it's understood that the exponent is 1. So what do you think will be the answer here? 1 plus 10 will give you y raised to 11 power. Right. Another example, if I have 2 to the second power times 2 to the third power. Okay, in this case, the base is 2. This still be multiplying powers with like bases. So all you need to do is to add the exponent. And it's going to give you 2 to the second power plus 3. Okay? And that is 2 to the fifth power. You can also expand this by multiplying 2 by 2 by 2 times 2 times 2 5 times, and that is 32. And our last example is negative 6x to the ninth power times negative 3x raised to the sixth power. As you notice, in this case, we have coefficients. And our coefficients are negative 6 and negative 3. And they are not considered like bases. But rather, you can multiply them simply applying the things that you have learned about integers. Negative 6 times negative 3. The answer is positive 18. And then this time, you can see now this time they have the same bases. X and X, they are the same. And then all you need to do is to add the exponent. So it will give you x raised to the 9 plus 6. The answer is 15. Okay, there you have it. This is the first law of exponent. Okay, before we proceed to the second law of exponent, I want you to think of this example. Suppose that I have here x raised to the third power raised to the second power. Okay. There is a parenthesis. If there's a parenthesis involved, it means that it is considered as 1. Okay. So in expanded notation of this one, this will be your entire base. This is your base. Okay? So therefore, x to the third power will be multiplied to itself twice. So it will become x to the third power times x to the third power. This is the expanded notation of this given. So therefore, as you notice, it become now multiplying powers with like bases. In multiplying powers with like bases, all we need to do is to add the exponent. So what do you have? What will be your answer? X raised to the 3 plus 3, the answer is 6. So what do you observe? Okay, that's the essence of math. You are making you simple, complicated things to be simple. Just simply multiply, this time the exponent. So 3 times 2 will give you 6. As simple as that. Okay? And this is our next law of exponent. So our next law of exponent is called raising a power to a power. Again, for any non-zero real number a and for any positive integers m and n. So if you can see this kind of given, all you need to do is to multiply the exponent. Let's answer some examples. Okay, so we have x to the second power to the fourth power. So again, it's simply what is stated on the second law of exponent. Just simply multiply the exponent. 2 times 4, the answer is 8. Simple as that. Okay, another example. Another example is y to the fifth power to the sixth power. The answer is y raised to the fifth power raised to the sixth power, or the quantity of y to the fifth power raised to the sixth power. So the answer is y raised to 5 times 6, the answer is 30. Okay. Before we proceed to the third law of exponent, I want you to take a look at this one. Observe. Okay? So, suppose that I have x to the second power y to the second power raised to another power which is to the second power. So, in expanded, this time, as you notice, this will be considered as your base. This is your base. X to the second power, y raised to the second power, times x to the second power, y raised to the second power. Okay? So, it become multiplying powers with like bases. Like bases are x and x, y and then y. Okay, so what do you think will be our final answer? Our final answer is x to the second power multiplied by x to the second power will give you x to the fourth power. And then y raised to the second power will give you y to the fourth power. Okay. And that is our law of exponent number 3. That is called raising to a product to a power. Raising to a product to a power. For any non-zero real numbers a and b, and for any positive integer m. So, we'll give you a raised to m, b raised to m. Let's try some examples. Suppose that I have a to the second power, b to the third power, quantity raised to the second power. So, meaning, a to the second power times 2, okay, b to the third power times 2. All you need to do is to simplify them. So, a to the fourth power, b to the sixth power. That is our final answer. Okay? Another example. Suppose that I have c to the fourth power, d to the third power, quantity to the second power. Okay, there's another way of solving this one. Okay, you can also do the expanded notation of this given. It can be c to the fourth power, d to the cube, or d to the third power. You will multiply the entire base to itself twice. C to the fourth power, d to the third power. That's the other way of solving. Okay. So, what do you think is your final answer? Okay, same basis. All you need to do is to add the exponent. It become what? C, 4 plus 4 equals 8. D cube, the answer is d raised to 6th power. Okay, so what have you noticed, guys? In the reason why we are having laws of exponent is just only giving you the technique for you to be able to solve it easily. Okay, let's recall again the 3 laws of exponents for multiplication. The first one is multiplying powers with like bases. So just simply add the exponent. That's the first one. Okay. The second one is raising a power to a power. All you need to do is to multiply the exponent. And the third one is raising to a product to a power. Okay. Just simply a raised to n and b raised to n. Okay? If you have any more questions, just don't hesitate to ask question. Okay, I hope that you learned something today. And for the next lesson, I'm going to teach you how to multiply polynomials. That's all, and have a good day.